In the beginning, there was quark consomme, a thick gumbo of unattached atomic particles called into existence by the dark energy behind the Big Bang. This soup was so dense that even light itself could not travel very far without bumping into other particles.
Initially, you had this very, very hot universe, really high temperatures, but it was cooling off, cooling off, cooling off. It's as if, in those very early times, we're in the center of the sun. And you can imagine that light in the center of the sun bounces around, it scatters off of the electrons, photons are scattering off of electrons. And being inside the sun is like being inside a fog bank, because light is just scattered all over.
500,000 years go by before light escapes into the infinite universe. And this, the last scattering of the primordial fireball, leaves a detailed imprint, embossed in the microwave background radiation of the sky. Building in the tracks of this radiation, a filamentary framework develops, an underlying lattice for galaxies yet unborn. Knots of starbursts signal the arrival of those galaxies, and at once they begin colliding, merging, restructuring, growing.
What we're seeing here are remnants of the primordial seeds. Now, by the primordial seeds, I'm now talking about the first tiniest fraction of a second. In the first tiniest fraction of a second, then, there were little irregularities, and these irregularities grew into what we see now.
The universe today is a product of this hierarchical clustering, and clustering is opposed by the expansion of space itself. When tightly joined in groups and clusters, galaxies do not move apart. Captive within a common gravitational well, they gradually collide and merge.
They are always changing. Everything is changing all the time. These galaxies are in relative motion. First of all, they're expanding with the universe, and that's the basic thing that's going on. But more than that, they're actually sloshing around due to their mutual gravity.
Gossamer filaments can develop if the gravity of galaxies fails to counter the expansion of space. Then, adjacent galaxies can be sheared apart into bead-like or sheet-like designs. Some of the galaxies in a filament may ultimately fall back into a cluster, like a failing rocket at a loss for escape velocity. But if current theory holds, and the cosmological expansion is truly accelerating, most of these glorious filaments will shred away. Then, the deep time future of everything will look lonely and dark, with a very few neighbors receding from one another. Perhaps, in the universe of today, you're exploring deep space at its most beautiful.